Let's look at the first problem in the pure mathematics paper. Right. So this is the induction problem. So we have to prove that this statement is true by induction. So let's do the first step. When n equals 1, let's look at the left hand side. Left hand side is 1 into 3. So 3. Right hand side is what? Again substitute 1. And when you simplify, that is again 3. So true when n equals 1. Right. Then let's assume this is true when n equals k. So that means 1 times 3 plus so on until plus k times 3k is going to be what? 2k minus 1, 3 times 3 raised to k plus 1 plus 3 over 4. Right. Now this is true. So we assume this is true. Let's mark it as equation star. Now let's add the k plus 1 term to both sides of star equation. So add k plus 1 times 3 raised to k plus 1 to both sides of star and simplify the right hand side until you get the required result. So left hand side is this now, that is what we want. Right hand side we have to simplify. So we have k plus 1 times 3 raised to k plus 1. Right. Take the common denominator and simplify. 2k minus 1 times 3 to the k plus 1 plus 3 multiply by 4, you get what? 4k plus 4 into 3 times k to the plus 1 over 4. Now group the 3 to the k plus 1 terms, you get what? 2k and 4k, you can add 6k, minus 1 and plus 4 is 3. So this times 3 times 3 to the k plus 1 plus 3 over 4. Right. We want a plus 3 and 4. No? So those are already there. This 3 and this plus 4 we have. Now we have to simplify this part. Right. So look at 6k plus 3. You can take a 3 out. So do that. So you will end up with 2k plus 1 inside 3k plus 2 now. 3 to the k plus 2. Because we took a 3 out now. So we already had 3 to the k plus 1. So 3k plus 2 is what we have. Plus 3 over 4. Right. Then this one can be written as what? I will write like this. What is inside this bracket? I can write it as what? 2k plus 1 minus 1. Same thing, no? And this power I will write it as 3k plus 1 plus 1. Right. So this is what? The required statement. So this is true for, look. This is the statement we want. K plus 1 here, k plus 1 here, plus 3 over 4. So we have that statement here. So statement is true for n equals k plus 1. Therefore, statement is true for n belongs to Z plus by mathematical induction principle. So that's how you prove the statement in question number 1. Next we'll look at question number 2.